So you can see that the little recording symbol is up in the right-hand corner. The only drawback to this is that it only records up to 30 minutes. So when it gets to 30 minutes, it automatically shuts off. So if you notice that that little recording kind of disappeared, just let me know it disappeared and I can hit record again. This way you won't miss anything if you have to go back and look at the videos later. Okay, so today we're going to, which may be a review for some of you, so it won't be hopefully too bad. I'm just going to do a quick review of functions. Okay, so for example, if you have y equals 7x plus 2, we can actually say that's a relation between x and y values. Oh, you can't see it? Is it a glare or is just not?
You put 2x.
Oh, okay, it's probably from my hand. Let me kind of clean that up a little bit. Relation between x and y values. Which means that if you make x equal 1, then y will equal a different number. You make x equal 2, y will equal a different number. You make x equal 3, y will equal something else. So that's just a relation between those two unknowns. Okay? Which means that relation can be written as a set of ordered pairs. Kind of clean that up a little bit. Now your ordered pair is just your when x equals one value, y will equal another. So your ordered pair can just be some x comma y. Okay. Which brings us to our domain and our range. Our domain is just every possible x value. Let me clean that up a little bit. And your range is just every possible y value. Just heads up, I have a tendency to write very fast and sometimes messy, so if something's unclear, just let me know so I can straighten it up. Okay, so let's say, for example, if we wanted to determine the domain and the range of the relations, let's say for problem A, straighten that up a little bit. There we go. Okay, so let's say for problem A, you have the ordered pair. I'm about to write A. Let's say 2, 3, say 2, 4, say 0, -1, say 3, -1. Okay, so that's just a set of different ordered pairs. Okay, say for problem B, let's say we have -3, 1, -2, 1, -1, 1, and 2, 1. Okay, so the solutions to those would be, for A, remember your domain is every possible
number.
X value.
2, 0, 3?
Yep, so it would be 2, 0, and 3. Because remember, it's just X comma Y. So the first component is always going to be your X. The second component is your Y. Bless you. So your domain is 2, 0, 3. And your range, which is every possible Y value, which is 3, 4, and -1. Let me write a little. Or -1, 3, and 4. Okay. So even if they repeat like the 2 did for the domain, you only write it down one time. You don't have to write it down multiple times. We'll bring that up a little bit. Okay. Any questions on that one? All right, so let's do a quick example for B. Well, not finish this example up. Your domain for B. Remember, that's every X value. So that's -3, -2, -1, and 2. And your range, I'll put that underneath it, is every possible Y value, which is 1, 1, 1, and 1. So that would just be 1. All right. So any questions there? All right. Leave that up for a few seconds. Okay, so let's say if we have, just a quick heads up, I also scan the notes and we'll upload them to Canvas, so you'll see a little link where it'll say Class 1 Notes right up underneath your homework. So even if I happen to go past something or you come in late, the notes will be uploaded later that day. Okay, so let's say if we have two boxes here where this is your input, which in this case would be cities. Okay, let's say we have Lubbock, Colorado Springs. So we have Omaha. And let's say we have Sacramento. Okay, and let's say we have our output, which in this case would be population. Clean that up a little bit. which is in the thousands. Okay, so let's say the first one is 370,000. Say the second one is 197,000. The third one is 404,000. Fourth is 35,000. So you have 445,000, 206, and 197. Which are more than we actually need. Okay, so let's say Lubbock, if we know that is 206,000. Okay, so what if Colorado Springs, we know that's 370,000. Okay, say Omaha's 404,000, and Sacramento's 445,000. Now, if it's set up like this, your input, you can think of that as just your X values. And your output, think of that as your Y value. So remember, your domain is all possible X values, or all possible input values. So they're not always values. Sometimes they're cities, sometimes they're cars. They could be anything at all. So whatever's in that input will be your X values. Okay, so that means your domain would be Lubbock, Colorado Springs, Omaha, and Sacramento. Okay, so that's your domain. Okay. Now your range, remember your range are all possible Y values, which means everything here are possible Y values. They're not matched up with anything, at least all of them aren't, but they're possible Y values. So everything here would be your range. So that would be 370, 197, 404, 35, 445, 206, and 197. Oops, straighten that up a little bit. All right. Any questions on that so far? Okay. Now, if we wanted to write an actual relation, then we write out which ones match up. Okay, which would be Lubbock. And we know that matched up with 206. Colorado Springs, we know that matched up with 370. Omaha, we know that matched up with 404. And we know Sacramento matched up with 445. Okay, so remember, your relations is always going to be just X comma Y, or your ordered pair. All right. So any questions on that so far? Yes. Bless you. Which one?
197.
Oh, I wrote 197 twice? Oh, you're right. Nope, you only have to write it once. I didn't catch it. Thank you. Actually wrote it twice so I could point that out, but I completely forgot to point that out. Thank you. All right, leave that up for a few seconds. Ladies, he can't have you talking like that. Okay, anyone still writing? All right. Okay, so now we're going to get into functions. A function is just a special type of ordered pair. So a function is an ordered pair. Oh. I think as soon as I move the pencil, it kind of brightens up. I know it's odd like that.
I think if we close the light, it's better.
Actually, it is down. It's just a very thin blind.
Or you can just do it more like closer, probably.
Yeah, zoom it out.
That usually helps. The only problem is it only focuses on a small section. So what I'll do is I'll try to move my pencil a little more so it doesn't have that shadow. Let me clean that up some. Okay, so function is an ordered pair. Which has each first component corresponding with exactly one second component. And that exactly one is kind of an important detail, so exactly 1 second component. Okay, so let's say, for example, if we wanted to determine if a group of ordered pairs represent a function. So determine if the relation is a function. Okay, so let's say for problem A, if we have the set of ordered pairs, -2, 5, 2, 7, -3, 5, and 9, 9. That's supposed to be like a little bracket at the end of it. Say for B, let's say if we have the set of ordered pairs, -4, 2, -3, 8, 7, 8, and 4, 2. And let's say for problem C, you have -1, 4, 0, 5, say -1, 3, and 2, 0. All right, so we got our solution to A. Is that a function or not a function? Yep, it is a function because every x has exactly one y. So -2 has a y component of 5. You don't see -2 having a different y component. Same with 2. You don't see it having a different y component. So as long as each first component is only matched up with exactly one second component, you're okay. Yep, so this is a function. So it is a function since every x value has exactly one y value. Okay, so what about B?
Function.
Yep, it is a function. It's here, -4 only has one y value. Same with -3, same with 7, same with +4. So you only have one y value.
I have a question.
Sure.
So x can have only one value, like only one.
Mm-hmm.
For y, you can like here -4 and 2 and 4 and 2. So 2, it's like.
Yep, so
Yeah.
x can only have one y, but y can have more than one
than
x.
x.
Mhm.
Okay.
Yep, exactly. That's the one thing you have to remember about that one. Okay. So is a function since every x, oops, has exactly one y value. Okay. So what about C?
It's not a function.
Yep, it's not a function. Only because, if you notice, -1 has a y value of 4, but -1 has a different y value of 3. So remember, -1 can only have one y value. If you have more than one, it's not a function.
It's a relation, but it's not a function. Right?
Oh yeah, it's a relation, yeah, but not a function. Okay.
Because like if the number they're the same thing, so that means they're not function. Like if we have -1 and -1, so it would be not function. Yeah.
Oh, you mean if both of these are -1?
Yeah.
Oh yeah, it could still be a function as long as -1 doesn't have a different value later on.
Okay.
Yeah.
Like if we have another -1 and 4,
Mhm.
it's gonna be function because it's the same thing. Because 4.
So it's not a function. Since x equals -1 as y equals 4 and y equals 3. Okay, remember, each x can only have one y. All right, so any questions on those? All right. Leave that up for a few more seconds. So it's at 24 minutes. Might as well.
you're saying if
Mhm.
y has the same numbers, it's still a function.
Yep, still a function, as long as,
Has to-
yep, as long as each x has a different one. So if you have -1, 3, and you have 2, 3, it would still be a function. Yeah, you're welcome. So really, if you look at B, that's an example of that one. So if you see the first one, -4, 2, and 4, 2, the y's can be the same and it can still be a function. So as long as you don't have -4, 2 and -4, 1, then that wouldn't be a function. All right. Just those little minor details. All right. So let's say for our next example, when we don't have a list of ordered pairs, but they just kind of give us a function. I mean, an actual equation. So determine if the relation is a function. Okay, so let's say for our first example, say y equals 3x minus 5. And let's say for b, x equals y squared. And let's say for c, just add one in there. Say y equals x squared. Okay. Now I'll give you a quick hint. Whenever you see a linear function that's not a vertical line, it's always going to be a function. So as long as it's not like x equals 4, which is just a vertical line, it will always be a function. Okay. So we know if we plug in different values of x, we'll get a different value of y. If you plug in x equals 1, you'll get 3 minus 5, which is -2, so you'll have 1, -2. If you plug in a value of 1, you won't get anything different than that -2. Same thing if you plug in 0, you'll get -5. If you plug in 0 again, you'll always come out with -5. So you know that a is always going to be a function. As a function since every x value has one y. We're almost at 29 minutes. Let me just stop it and restart.